For this Ram 2500HD with the 6.4 Hemi P0301 means the PCM is seeing a cylinder 1 misfire pattern. The PCM watches crankshaft speed changes to pick up a single cylinder misfire. The truck may run rough, stumble under load, idle unevenly, set or flash the MIL, and on some equipped trucks stop/start may be disabled while the code is active. Broadly, this kind of fault can come from ignition, fuel delivery, air leaks, connector problems, valvetrain or compression issues, oiling or VCT concerns, carbon buildup, or a control side problem. Start with the basic system checks and follow a structured diagnostic approach. Do not assume the coil or plug is bad just because the code names cylinder 1. Before chasing the fault, make sure the misfire monitor has a fair chance to run. The monitor gates include fuel level above 12%, battery voltage above 9 volts, ambient temperature above -23 degrees C, -4 degrees F, and coolant temperature at engine start above -7 degrees C, 4 degrees F. If start engine temperature is below threshold, the monitor is enabled when engine temperature reaches 21 degrees C, 8 degrees F, and the engine speed gate is between approximately 400 RPM and 6,200 RPM. Then turn the ignition on, record the stored and captured data, and reproduce the captured operating conditions. During the road test, pay attention to when the misfire actually shows up, and watch the downstream oxygen sensor behavior while it is happening. Low-side readings point you toward a lean condition, like a lack of fuel from a restricted injector or fuel system issue. High-side readings point toward too much fuel reaching the catalyst, which can happen with loss of spark or a leaking injector. Then use the misfire monitor to confirm whether cylinder 1 is showing excessive misfires right now. If it is not active, treat it as an intermittent condition instead of forcing a guess. Also remember that during a severe misfire, the PCM can shut off the injector for the affected cylinder to help protect the catalyst, so a high-load misfire can appear to continue when you come back to idle until that strategy resets. Next, look at the other recorded codes. If there are active or pending codes in the fuel system, ignition system, air handling system, VVT system, or VVL system, deal with those applicable paths first. If none of those are active or pending, stay on the cylinder 1 misfire path. Now do a careful inspection before getting buried in pinpoint testing. Look for belt problems, accessory pulley misalignment or binding, poor sensor mounting at the crank, cam, or MAP sensors, poor connector or terminal contact at key engine components, weak PCM powers or grounds from corrosion, vacuum leaks, intake or exhaust restriction, signs of internal engine trouble, moisture on ignition parts, fuel supply or fuel quality concerns, and operating load conditions that could be contributing. Anything that changes crankshaft speed can make this code set, and a misfire may not always be caused by a failed part. If you find a real problem here, correct it and verify the repair before moving deeper. With the ignition off, inspect the MDS solenoid connectors and related jumper connectors. Check connector seating, locks, corrosion, water intrusion, seals, bent or overheated terminals, push-back terminals, spread terminals, and terminal tension. Correct anything found and verify. If that checks out, inspect for mechanical conditions that can mimic or cause a misfire. Belt slip, binding or misaligned driven accessories, crank sensor mounting or target wheel damage, an out-of-balance harmonic balancer, and severe tire or brake rotor imbalance. Then check the engine and intake manifold for vacuum leaks, because a leak can affect one cylinder or several depending on where it is. After that, check fuel quality and level concerns. Water, wrong fuel type, old or contaminated fuel, low fuel, and the ethanol level. If the fuel is bad, replace it and clean or flush the system if needed, then verify the repair. For the injector check, use fuel pressure decay tester 8978A at the fuel rail. Before opening any fuel line or fitting, release fuel pressure. This system can stay under pressure even with the engine off, and that is a serious safety concern. Key on and let rail pressure reach maximum and stabilize. The ignition may need to be cycled off and on a couple of times to reach maximum fuel pressure in the rail. Record that as the starting pressure. Command the cylinder 1 injector with the scan tool while watching the gauge, then record the ending pressure. Repeat the same process on several good cylinders, always starting each injector actuation from the same starting pressure, and compare the ending pressures. The reading should be about the same. If cylinder 1 stands out with too small a pressure drop, look for debris in the rail or injector and correct it. If the pressure drop is too large, suspect a fouled or leaking injector. After each injector actuation, start the engine to clear fuel from the cylinder. Skipping that can damage the engine. After the injector test, turn the ignition off, remove the fuel pressure decay tester and reconnect the fuel lines before continuing. Remove the ignition coil from cylinder 1, reconnect the coil connector, disconnect that cylinder's injector connector, install a spark tester and crank the engine. You are looking for a crisp blue spark. If spark is missing, move to the ignition power and control checks. If spark is good, turn the ignition off and inspect the spark plug and cylinder. Look for cracks, carbon tracking, oil, coolant, excess fuel fouling, incorrect gap and loose or broken electrodes. Also check for oil or coolant in the cylinder. If the plug has one of those faults, replace the spark plug. If oil or coolant is present in the cylinder, diagnose and correct the cause, then verify the repair. If the plug and cylinder inspection do not show the problem, run a compression test on all cylinders and compare the known good cylinders to cylinder 1. If cylinder 1 compression is not within specification, use a leak-down test to separate valvetrain trouble from a combustion chamber sealing problem, correct the fault, and verify. If compression is within specification, swap the spark plug with a known good cylinder that is not misfiring, or replace the plug if access makes swapping impractical. Start the engine and watch the misfire monitor. If the misfire follows the plug, replace that plug. If the plug was replaced and the misfire is gone, the repair is complete pending verification. If the misfire stays on cylinder 1, continue. Next, clean carbon from the valves and combustion chambers using MOPR combustion cleaner. After driving and clearing the cleaner from the engine, erase the codes, reproduce the captured conditions, and watch the misfire monitor. If the misfire does not return, the carbon cleaning corrected the fault. If it does return, check engine oil level and condition before going farther. Look for mechanical tolerance concerns, oil pressure concerns, low oil level, the wrong oil filter, dirty or deteriorated oil, contamination, incorrect viscosity, and aerated oil. These checks matter because skipping them can lead you in the wrong direction. Then check VCT solenoid operation. Reconnect the PCM-C2 connector, turn the ignition on, and measure voltage on the VCT solenoid control circuit at the solenoid connector. The VCT solenoid driver circuit is a 12-0-volt PWM circuit, so the voltage should be present and should roughly match the actuation percentage selected. If it does not, repair the VCT solenoid driver circuit for an open or short to ground and verify. If VCT control checks out, inspect the camshaft lobes, rocker arms, and springs for excessive wear or broken parts. If you find a valvetrain issue, perform the appropriate mechanical repair and verify. If nothing is found there, move to the final connector and control checks. If the earlier spark check did not show a crisp blue spark, test the ignition coil feed and control circuits. Keep clear of the fan, pulleys, and belt anytime the engine is operating, and do not wear loose clothing around the rotating parts. With the ignition off, disconnect the ignition coil connector. Turn the ignition on, command the ASD relay with the scan tool, and use a 12-volt test light connected to ground to probe the ASD relay output circuit at the coil connector. The light should illuminate brightly. If it does not, stop the actuation. Repair the open or short to ground between the PDC and the ignition coil connector, and verify. If the feed is good, connect a 12-volt test light to a 12-volt source and back probe the coil control circuit at the ignition coil connector. Crank the engine for 5 seconds. If the light blinks brightly, the control is present and the ignition coil is the fault. If the light stays on constantly, check the coil control circuit for a short to ground. If the light stays off constantly, check that circuit for an open. Do not probe the PCM harness connectors directly. Use GPEC Diagnostic Adapter 10436 for that part of the test. For a control circuit short to ground check, turn the ignition off, disconnect the PCM-C2 connector, install the GPEC Diagnostic Adapter on the engine harness side, and check continuity between ground and the coil control circuit at the ignition coil connector. If there is continuity, repair the short to ground and verify. If there is no continuity, continue to the final connector checks. For an open circuit check, measure resistance in the coil control circuit between the ignition coil connector and the adapter. The resistance must be below 3.0 ohms. If it is not below 3.0 ohms, repair the open or high resistance in the coil control circuit and verify. If it is below 3.0 ohms, continue. At the end of the path, disconnect the PCM connectors, any related inline connectors and related component connectors. Inspect connector seating, locks, corrosion, water intrusion, seals, bent terminals, overheated terminals, push-back terminals, spread terminals, and terminal tension. Repair anything found. Then reconnect every PCM, inline, and component connector fully, making sure the locks are engaged. Erase the codes. Operate or road test the truck under the monitored conditions and read codes again. If P0301 does not return, the wiring or poor connection problem has been corrected. If P0301 does return after this path, replace and program the PCM, then verify the repair and confirm the code stays gone. The takeaway is simple. Prove the misfire is active, separate fuel, spark, air, mechanical, and control issues in order, and verify every fix under the same conditions that set the code. For more diagnostic training, visit stepdiagnostics.com.